Now let us consider a uniform ring of mass m and radius capital R. The gravitational field at any point at a distance r on its axis is given by the formula gmr by capital R square plus R square whole to the power 3 by 2. This is for finite distances comparable with the radius of the ring. For very large distances, when small r becomes very much greater than capital R, this can be neglected. Then this will become E is equal to gm r by r cube, that is gm by r square. At large distances, even a ring can behave as a point mass. Now if you consider a point at the center, small r is equal to 0. Here small r is there in the numerator. If you substitute small r is equal to 0, the gravitational field will become 0. The variation of gravitational field with distance is shown here. At the center it is 0. As we move away, first it increases. It becomes maximum at a distance equal to radius of the ring by root 2. After that it decreases. At large distances, the ring will behave as a point mass. Now let us consider the gravitational potential. The gravitational potential at any point on the axis is given by the formula V equals minus gm by under root capital R square plus small r square. If we consider very large distances as before, small r very much greater than capital R can be neglected. Under root small r square, that will become r, so it will be minus gm by small r. That means here also, for as far as potential is concerned, the ring is behaving as a point mass. Now let us consider a point at the center. At the center small r becomes 0. So this will be minus gm by under root capital R square, that is minus gm by capital R. The variation of gravitational potential with the distance on the axis is shown like this. Sometimes the graph will be shown like this also. In the earlier case, when we have considered the gravitational potential due to a solid sphere, at the center it was minus 1.5 gm by r, that we have shown on the negative axis. The graph can be drawn this way or this way. Don't get confused. You just select the proper thing. Here I have written minus gm by r. Okay? I hope it is clear to you. With this, the variation of gravitational field and gravitational potential in 3 cases we have discussed.